Welcome to a new section, Mastering the Jupyter Notebook. In this section, we will explore several advanced features and usage examples of the Jupyter Notebook. As we have only seen basic features in the previous section, we will dive deeper into the architecture of the notebook here. The first video will walk you through the architecture of the Jupyter Notebook. Jupyter implements a two-process model with a kernel and a client. The client is the interface offering the user the ability to send code to the kernel. The kernel executes the code and returns the result to the client for display. In the read, evaluate, print loop, that is REPL terminology, the kernel implements the evaluate, whereas the client implements the read and the print of the process. The client can be a Qt widget if we run the Qt console or a browser if we run the Jupyter Notebook. In the Jupyter Notebook, the kernel receives entire cells at once, so it has no notion of a notebook. There is a strong decoupling between the linear document containing the notebook and the underlying kernel. All communication procedures between the different processes are implemented on top of the 0MQ, that is ZMQ messaging protocol. You can read about it at 0mq.org. The notebook communicates with the underlying kernel using WebSocket, a TCP-based protocol implemented in modern web browsers. So how could you connect multiple clients to one kernel? In a notebook, typing modulus connect info in a cell gives the information we need to connect a new client, such as a Qt console, to the underlying kernel. And here's the output. Here, app is console, Qt console or notebook. There is also something called Jupyter Hub, available at jupyterhub.readthedocs.io, which is a Python library that can be used to serve notebooks to a set of end users, for example, students of a particular class or lab members in a research group. It handles user authentication and other low-level details. It is possible for an attacker to put a malicious code in a Jupyter notebook. Since notebooks may contain hidden JavaScript code in a cell output, it is theoretically possible for malicious code to execute surreptitiously when the user opens a notebook. For this reason, Jupyter has a security model where HTML and JavaScript code in a notebook can be either trusted or untrusted. Outputs generated by the user are always trusted. However, outputs that were already there when the user first opened an existing notebook are untrusted. The security model is based on a cryptographic signature present in every notebook. This signature is generated using a secret key owned by every user.